Okay, good to see you back. And I'm really happy to present you Plamen Petkov from Fast Market, a Kubernetes specialist. And he will talk today about the Fleet Commander. And I'm really curious to reach out all of the things. Good luck.
Thank you. Thank you. Hello, everyone. Nice to see you all. Today, I'm going to share a story of how my team and my organization transformed the way we use Kubernetes and the way we launch it. So, why is it called Fleet Commander? It's because it's the name we gave to the hub and spoke paradigm, which I'm going to speak about in a second. First, a little about me. I work as an SRE for Fast Markets. Fast Markets is a price reporting agency in the UK. Think about it as streaming of real-time data, of commodities, prices of oils, wood, things like that, right? We are here to speak about Kubernetes anyway. I have extensive experience as DevOps. Before being a DevOps, I was working for Red Hat selling OpenShift, so this is how I transitioned from non-techie into a total Kubernetes nerd. I'm also a fellow home labber, so almost everything I try in the company, lately in production, I test first in my home lab. Next year, I can include a picture, but it's too messy to, to show for now. And I have experience with all kinds of Kubernetes deployments in almost every major cloud managed Kubernetes, air-gapped environments without internet access, and strong security concerns, and also on-prem. I like on-prem. It's actually my favorite, but you don't get to see that much nowadays. So these are my two questions that I start the presentation with. How many of you manage Kubernetes clusters? Okay. And when the complexity gets going, how much of you actually enjoy doing that? Okay. We have some fellow warriors in here. Okay. Let's see. So, our journey in Fast Markets, in the beginning, we had lots of microservices, which you could say that it's really a good sign, but if they aren't managed well into an orchestrator like Kubernetes, it's a whole nightmare. So, we started adopting Kubernetes, but in the beginning, we had single cluster deployments of the most modern teams, the most bravest warriors. And at some point, that complexity of managing single clusters grew linearly, as we are going to see later as our main pain points. But here, we have a happy ending. This is the story of how we ended up managing an entire fleet in an automated fashion, in a fun fashion, and in a fashion that I dare to say that's actually enjoyable. So let's see how we did it. This is the beginning where some of the first teams started requesting my team, the SRE team, to launch infrastructure for their Kubernetes clusters. So, as a fellow SRE, we use Terraform extensively, so we started making a simple AKS template, right? To accommodate their needs, specific VNets, specific subnets, everything in Terraform. And so far so good. To launch one cluster, that was absolutely fine. But here we find the first pain point. The deployment is automated with the infrastructure as code. Yet after that cluster is up and running and living, everything else is manual or depends on the teams. Also, the procedure is not idempotent at all. This cluster, after applied, if you try to apply it again, it will end up destroying something, or it will drift with the time, with the more the developers use it. So this is a list of our pains. Copy-paste engineering. This is your worst enemy. After we had this template I showed you, people started doing copy-paste of the template and putting it into different repos to accommodate new projects, new teams, and it ended up being a disaster because this copy-paste engineering created a huge configuration drift. So if we optimize the template in one repo, you don't have guarantees that that optimization or fix is going to be applied everywhere else where people copy-pasted it. Eventually, if it's in production, you don't have even permission to fix it right away. The second and biggest pain point as well is when complexity starts growing and you have 2, 3 more clusters for different teams, you don't have a central place to have observability, a central place where you can look and see the health of everything. You have to build it or buy it. So by the end of this talk, I hope you all are with enthusiasm to build it rather than buy it, but we'll see. Another pain point we had is the operational tasks that we had grew linearly, and the overhead and difficulties grew linearly the more clusters and more teams that are using Kubernetes in the old fashion with the template I showed you a little earlier. So at some point we had a lot of business as usual tasks every day related to simple stuff that could be corrected into one central place. And these two last pain points that I have are my biggest nightmare. This is when every team starts doing whatever they feel like as a practice regarding Kubernetes. So they start implementing different pipelines, different deployment methods, different deployment strategies, health checks, or the absence of everything that I mentioned as well can be the case. And the worst thing as well, people that aren't proficient at all in Kubernetes doing Kubernetes operations because they have access to a kubeconfig file. That's the nightmare of every DevOps and SRE. So I'm going to introduce you to a nice concept we came with when building the AKS Fleet Commander. And it's this concept of building a taxi company. So in the beginning, in this situation that I put you in with the multiple clusters deployed with the same copy-paste template, different practices and all mentioned, you have a gang of drivers that you don't have no way to manage, no way to manage their orders and clients, and no way to manage their practices. So you end up with the cool taxi guy with the cool car that has habitual clients and does his job perfectly. And you have the guy that smokes in the car before picking up a client. And you have also guys that are relying only on walk-ins, only on clients off the street. So they have no process. We had to build this central dispatch system. So this is where the thought of the AKS Fleet Commander was starting. Our solution, the AKS Fleet Commander, is actually hub and spoke architecture. Here you can see how it does work. It has a central brain, which is a central cluster. More like in the example of Carlos, the hotel. Here we have the brain, which is the hub, is a cluster just deployed to be that, to be the brains of our whole fleet. So in the center, we can see the AKS hub, which has below its two core components, the GitOps controller, which in our case is ArgoCD, and the observability stack. On its left, we have n number of clusters. They can be 100, they can be 1,000, and all are going to be managed by our brain cluster, our hub. We are going to get into more details a bit later, but in the architecture diagram, we can see that, I don't know if you guys can read it well, but we are sharing, the arrows are lost. So the GitOps controller is provisioning them, and they, in exchange, are sharing metrics, logs, traces to our observability stack. We'll see in a bit how that is being done. But going back to our journey, how we formed this thing. The AKS Fleet Commander wasn't built overnight, just as Rome wasn't built overnight. So here you have a little snippet of how much iterations it took until we had a good Terraform AKS template. As simple as that. Took like almost 1,000 commits in the repo. So this is a lot of trial and error until you get this perfect template. That's the golden recipe. The golden recipe that's like that food that you will always like and eat, right? That's the golden recipe. That's your perfect Kubernetes AKS Terraform template. That was in our case. Once we had this template, which now I'm going to show you why is that golden recipe. It is because it's highly, highly configurable. You first need to come down to a set of instructions that you need to give to the infrastructure as code so you receive what every team may eventually need. So you have to stop and think about those necessities before creating the recipe. But in our case, I'm showing you a little snippet of what the recipe when being used look like, and the recipe as the end product only relies on variables. Those variables are like switches of features and configuration for the cluster that your team may need. So in the first 4 lines, we have a decision of which type of node pools we need to give our team. Is it a data team using AI? Do they need GPUs? Are they using lots of memory intensive VMs? Are they using lots of CPU intensive? So here you enable these features, and below we are configuring them, which sizes we want to give to these VMs. Also stuff like the minimum and maximum count of auto-scaling. And this configuration is for all the node pools. But you can have additional switches, like cloud managed switches. Like, do you want them to have vertical pod autoscaler? Do you want to include some Azure Identity Workloads configuration? So you have to think about what kind of features you want to enable your developers to use in this recipe. And after having the recipe itself, you can scale to use it as much as you want. But yeah, it's the core part is having this recipe. Going back to the hub and spoke architecture, we use the recipe itself to provision the brain, the hub, and the workers. So we use the same Terraform for everything, absolutely. Just different variables files. But what makes the brains the brains? What are the core components of it? Its core components are the GitOps controller and the observability stack. We provision it with these both components, and they are what makes it this well-oiled machine of reconciliation. So the GitOps controller for ArgoCD, I think you all being in this community are well known with this term of GitOps by this time, but yes, it makes everything auditable, it makes everything visible, transparent, everybody can change one thing and it will be applied in the cluster, and it will self-heal. If somebody touches the cluster, it will fix that change and the person will be kind of frustrated, right? But they get what they deserve. They didn't change the manifest, they changed the state of the Kubernetes cluster. About the second component that's really, really core of our brains is the observability stack. We are using the Grafana stack, LGTM for short, Loki for logs, Grafana for visualization, Tempo for traces, and Mimir for metrics. Going back to our taxi metaphor, by this point, after we have provisioned the brains of this hub and spoke, we have provisioned a central dispatch system for our taxi drivers. With the golden recipe, we have provisioned a whole manufacturing process for the cars. So every car has a standard method of being created. Every car can be configured in the same standard way. So depending on the needs of your taxi company, if you have customers with babies, you can provision cars with baby seats. Or if you have customers with multiple families, with 5 or 6 people, you can provision bigger cars. All in the same standard way, from the same place, same process, no matter how much cars your fleet needs. The cars, after being dispatched, after rolling out of the line of manufacturing, they are already hooked to our central dispatch system. And most importantly, we are giving clear rules to drivers. Things like, you are not going to smoke in the car, you are going to use the system to pick up orders, and so on. These clear rules are the boundaries that GitOps define, boundaries that are also enforced by the controller. And also one of the nicest features is that you have consistent upgrades across the whole fleet. Because if you have, for example, a Helm chart that's being provisioned in 100 clusters, you can change the version only on one place and GitOps will take care of you. It will take care of the upgrade, and inevitably you will see it fail if something's gone wrong, and it's easy to roll back. So, if you're questioning, why did we choose the Grafana stack, LGTM stack? The response is really easy. It was because it's free. So, being free enabled us to iterate those hundreds of times until we got the brains working well. But yeah, it's free if you don't count the engineer hours, because I spent quite an embarrassing amount of time fighting values.yaml files from their different umbrella charts. Yeah. Transitioning into one of the best features of the Grafana stack, the multi-tenancy. This concept of multi-tenancy into Grafana makes it possible so you can have different traces and logs and metrics going to the same component of Grafana, but being split. The metrics, the data is never mixed up. And it's really easy to implement. I have included here a snippet of a Prometheus configuration, and it's really the 2 lines that say headers x scope org ID. In that moment, you're defining a tenant. It doesn't ask you for confirmation, it doesn't ask you for a UI, it doesn't ask you for any of that. You are defining that these metrics belong to this tenant. Then it's your job to visualize them when you're querying those metrics. Same goes for logs and traces. Every log that's being ingested and every trace that's being sent, if it goes with this header, automatically it gets separated into its own tenant. So, for example, here we are using an agent called Grafana Alloy that's basically a Swiss army for everything observability. It's literally a receiver, a shipper, pipeline processor for these observability thingies, and it does all into its own monolith style. So with these 6 lines of configuration, we are telling it to ship logs to Loki, our log component. And in the same fashion, we are telling it tenant ID, cluster production east, for example. I didn't want to talk about agents in this talk, but Alloy is really, really potent piece in our observability stack, because it can convert all type of protocols into different ones. So for example, it can transform traces from Jaeger format or act as a Jaeger receiver, but then feed them into our tempo. And same with Zipkin traces. Same with logs that, for example, are sys logs. So it can act as this pipeline that ingests everything into our own observability stack. I prepared a few slides to show you the type of traces that you can ingest. For example, here are traffic traces or linkerd traces. These traces are done by design to work with Jaeger, yet we are pointing the Jaeger endpoint to our Grafana Alloy, and we are ingesting them into our tempo, having this multi-tenancy as a feature by default. But the cool thing about these brains of the AKS Fleet Commander with the observability and every component is that we went beyond Kubernetes. We started observing all kinds of other workloads. Such workloads like VMs with all software running in there, stuff like SSL certificates or just websites and API endpoints. We started monitoring our on-prem from Kubernetes monitoring vCenter infrastructure and having different kind of metrics. And here you can see some of the configuration of the black box exporter doing checks to see if our websites are up and if the SSL certificates are going to expire. So here we see how the dashboards look like. Here we have the one for the SSL certificates and the websites, and the one for vSphere. I want to make a note here that having all this observability setup opened us a whole lot of work. So in the beginning was a nightmare because we started seeing lots of problems that we didn't even know. They didn't came as an incident. We just started seeing alerts. Because the cool thing is that you can configure alerts for everything that you can see from the dashboard. You can have an alert in Teams, as an email. So it's up to you to filter out the noise. That's also as a tip. For example, when we started seeing the vSphere on-prem infrastructure, we saw that we are incredibly over-provisioned and that we may scale a little bit into more VMs because we were basically not using capacity. We started monitoring any logs from any machine, any program that the developers may need some assistance from the SRE team. We just hooked an agent and asked the teams what they really want to monitor, what files, what logs, and they started self-serving themselves. So whenever they needed to debug an application, they didn't need any assistance at this point. So going back to our taxi fleet metaphor, now, after we provisioned the GitOps controller and observability stack, our central dispatch system knows where is each car, what it's doing, if it has clients or not, the levels of fuel. It monitors even stuff that's outside of the cars, like roads, infrastructure, news, weather, all within a single pane of glass, all within the central dispatch system. Doing the transition to the real benefits we saw as an organization after implementing this hub and spoke architecture, we really became more agile in terms of incident resolving, and our business as usual operational overhead really got reduced by 60%. The source is our Scrum Master. This is not made up. Our developer onboarding also sped up significantly because instead of fighting about giving access to a new developer, we had everything within the same OpenID Connect SSO. So we just onboarded the developer in that SSO, in the correct team, and they will get access automatically to their tenants in ArgoCD and in the observability stack. And one of the benefits that I felt the most is that the incident response time got cut in half. Because nowadays, when a team has a problem, they don't come and say, I have a problem. They come and say, here, this is a link of Grafana. I'm seeing that the CPU spiked. I'm seeing that Alloy stopped receiving the traces. I'm seeing a lot of errors in the logs, or I'm seeing that here we have a gap where we didn't receive metrics. Something's not okay. Or users are feeling it. We are seeing this problem. So the requester has access to the same things that we have access as SRE in the observability stack. So they come informed when they have a request. But these key benefits didn't come gratis, right? They didn't come for free. We had quite a few challenges as well. After all, it took more than 4 months to implement the hub and spoke architecture after we had this golden recipe. So one of the key challenges we had is with this multi-cluster, multi-tenancy, the networking is quite complex. And if you have VMs and machines you have outside of the cluster, you need to do a lot of network peering. You need to do a lot of network juggling. Also, each of those iterations broke the state of Terraform and opened a whole lot of manual deletion and manual work. So we became the bottlenecks at some point. Our solution was to pre-provision the automation. Pre-provision before attempting to create a new cluster. Create a VNet, create a subnet, create whatever Terraform may need before attempting to launch Terraform. And as a second pain point that got resolved this way was to teach teams GitOps principles since the very beginning. You don't deploy a single thing without GitOps. This needs to be learned, so you smooth sail since the beginning of your new architecture. So as advantages, I will start speaking a bit, a bit faster. As advantages, we saved tens of thousands just in observability. Don't get me on ready platforms that launch you the clusters. We have happier DevOps teams because building this architecture, it was all done with the resources we have. GitHub, Terraform, code, Azure, we are all in Azure, so we are not paying for additional stuff. And every member of the DevOps and SRE teams became more engaged. They liked suddenly what they are doing. They started working in their home labs as well. I'm not going to say they started working overtime, but somewhere doing pushes on the night. And we have the flexibility. You can ship features for your platform, or you can remove those if it's not being used. At the end of the day, it's transparent. You don't have vendor lock-in. So every problem is visible to everybody. Transparency and control. Yeah. There may be times when you can consider commercial options. This is, for example, when you needed an AKS fleet management platform yesterday, then you may consider buying something, because as I said, it takes months at best. If you don't have engineers with Kubernetes expertise, that's completely fine. Then you can go with ready solutions and that will be your go-to. Or if you have regulatory or compliance requirements that require you to buy a certain vendor, or you are already married with it. Our taxi fleet today rolls and sails smooth. Everything is visible. Our taxi drivers are happy. Our clients more. And remember, the goal isn't just to build the clusters. It's to enable your developers to build amazing and fun things on top of them. Here's a little checklist if you want to take a photo of how to get from 0 to 100 on your fleet commander. Basically what we spoke. First the template, then a streamlined process to launch those clusters, then a process to adopt those into the GitOps controller, and then see what tooling you need to provision. Provision dozens of those or hundreds. Thank you for listening. If you have any questions.
Okay, thank you, Plamen. It was very, very interesting, and I think you had a lot of questions. I just want to notify you that now it's a coffee break for 15 minutes, and after that, the next speaker, it will be at 3:30. So if you want to stay with Plamen now, or maybe in the coffee break to maybe have a conversation related to the subject, it would be
Anyone,
very cool.
if you have any questions, you can meet me outside also. Ask freely. Don't be shy.
So, yeah, congrats.
Thank you.